So dear students, we are going to continue with our last video, and today we are going to see similarities between Biot-Savart law and Coulomb's law. Similarities between Biot-Savart law and Coulomb's law. So I'm writing here Biot-Savart law of magnetostatics and Coulomb's law of electrostatics. So Biot-Savart law gives us the value of a magnetic field due to at any point due to a current element dl, and the value of the magnetic field will be B is equals to mu 0 by 4 pi, which is a constant, ideal sine theta divided by r square. So this is the value of the magnetic field due to this current element ideal. And from the Coulomb's law, it will give us the value of the electric field at any point due to any point charge. So it is 1 by 4 pi epsilon 0 q by r square. So this is the value of the electric field due to a point charge q. So the first similarity is, if you see at the denominator, so both varies with the square of the distance. Both the electric field and the magnetic field decreases by a value of r square as you move farther and farther away. So both obeys inverse square law. Number 2, magnetic field. If you see, magnetic field is due to a current element ideal, which is a vector quantity, and electric field, or the source of the magnetic field, is a vector quantity which is ideal, and the source of the electric field is due to a scalar quantity, that is charge q. So magnetic field is due to this current element. This is a vector quantity, and electric field is due to this scalar quantity q, that is charge. Number 3, if you see it, if for an electric field, if this is a charge and you're calculating the value of the magnetic field at this point P, which is at a distance of r from this charge, then if this charge is positive, then at this point the electric field will be outward. The electric field will be outward at this point, or the electric field will be along the line joining these two points, the source and the point at which you are calculating the electric field. See, the electric field will be along these two particular points. The point at which you are calculating the field and the charge which contribute to the field. So the field will be along these 2 points, or along the line joining these 2 points. But for a current element dl, where I current is flowing, at any point P, let us take at a distance of r, the magnetic field will be perpendicular to both this dl and this particular r, because magnetic field will depend on this ideal cross r. So the cross product of two will be either inward or outward of this plane of the paper, because dl and r both are in the plane of the paper. dl and r both are in the plane of the paper. That means the magnetic field will be perpendicular to both dl and r. So when you go from dl to r, so this is my four fingers are towards the dl, and when you curl it towards this r, when you curl it towards this r, then your thumb will gives you the direction of the magnetic field, which is inward. So for a cross product, the the result of two cross product will be perpendicular to both these two quantities. That means the magnetic field will not be in this line, but it will be perpendicular to this line. So the third similarity is this one, and the fourth similarity is it's not exactly the similarity, but it will give you a property. The permittivity of the free space epsilon 0 and the permeability of the free space mu 0, when you multiply this two, and suppose mu 0, I am writing it as 4 pi mu 0, and for an epsilon 0, I can write this as, number 4 mu 0 into epsilon 0 is equal to epsilon 0, I can write it as mu 0 by, for mu 0, I can write it as mu 0 by 4 pi, and for epsilon 0, I can write it as I can write it as number 4 pi epsilon. Okay, I can write it as 4 pi epsilon 0. Okay, 4 pi epsilon 0. So the value of the mu 0 by 4 pi is actually 10 to the power minus 7 into the value of 4 pi 0. 1 by 4 pi 0 is 4 pi 0 is 1 by 4 pi 0 is 9 into 10 to the power 9, but it is here it is okay, it is 1 by 4 pi 0 is 9 into 10 to the power 9, but it is here 4 pi epsilon 0 only, so it is 1 by 9 into 10 to the power 9. So when you take 10 to the power minus 7 down, so it becomes 10 to the power plus 7 into 9 into 10 to the power 9. It will be 1 by 3 into 10 to the power 8 whole square. So this is nothing but it is the speed of light. Speed of light. That is c. So it is 1 by speed of light square. So permeability of free space into permittivity of free space is, when you multiply it, you get 1 by c square, where c is the speed of light, or speed of light will be equals to 1 divided by root under a mu 0 into epsilon 0. So this is a very very beautiful relation. Speed of light is equals to 1 by root over permeability of free space into permittivity of free space. So these are the similarities between the Coulomb's law and Biot's law. So this is it for today. Thank you.